Welcome to Brain Vision.
For this question, we have to use Newton's second law. So let me adopt my reference frame as this one. This is my y-axis and this is my x-axis. Now let us apply Newton's second law to the case A for the block number 1. So we are in case A, and then for block number 1, x-axis, we have the following. The net force acting in block number 1 in the x direction is equal to the mass of that block times its acceleration. The net force on the x-axis that's acting in block number 1 is composed by only one force, which is this contact force exerted by block number 2 on block number 1. Then, the contact force is equal to the mass of the block number 1 times its acceleration, which is at now. Now, we can apply Newton's second law on the y-axis. By doing that, we get the following. The net forces acting on the vertical direction is equal to the mass of block number 1 times its acceleration on the vertical direction. Since it's not moving and will not move on the vertical direction, its acceleration is equal to 0. Then, normal number 1 minus weight number 1 is equal to 0, meaning that normal number 1 is equal to the weight number 1. Now, we do the same for block number 2. For block number 2, on the x-axis, we get the net force acting is equal to the mass of block number 2 times his acceleration, which is equal to the acceleration of the block number 1, because they are moving together. Then, the net force is composed now by two forces, the contact force and the frictional force. So, we get contact force that points to the positive direction minus frictional force that points to the negative direction is equal to the mass of block number 2 times its acceleration. Before moving further, let I correct something that I have forgot. This force isn't positive, because this is the contact force that block number 2 exerts on block number 1, and it points to the left. So in our reference frame, it is a negative force. So minus Fc is equal to m1 times the acceleration in the x direction. Now continuing, for block number 2, y direction, we get the following. The net force acting on that block, on that direction, is equal to the mass of that block times its acceleration on that direction. It will not move in that direction, it's not moving, so the acceleration is equal to 0. There are only two forces acting on the vertical direction, which are the normal force pointing to the positive direction and the weight force pointing to the negative direction. Then the normal number 2 is equal to the weight number 2. Now, by doing that, we get 4 equations. 1, 2, 3, 4. Of course, we have to discover what is the contact force and then what is the acceleration. So we must work with these two equations that includes both of these factors. Let me call this equation 1 and this other equation 2. If we add equation number 1 and equation number 2, we get minus Fc plus Fc minus Ff is equals to m1 plus m2 times Ax. Therefore, the contact forces are simplified and we end up with minus Ff is equals to m1 plus m2 times Ax. Then, the acceleration in the x direction is given by minus frictional force divided by m1 plus m2. This equation will be very useful during this question, so I will put it up there on the board. Now that we know the acceleration, we can go back either to equation number 1 or equation number 2 and calculate what is the contact force. It's much simpler if we use equation number 1. Then I will be using this equation. So according to equation number 1, the contact force is given by m1 with a minus sign times Ax, but Ax is given by minus Ff divided by m1 plus m2. So we got m1 times Ff divided by m1 plus m2. So these are the equations for the contact force and for the acceleration on both cases. So now we just have to use these equations and calculate for both items A and B. Let me clear the board and finish the question. The contact force in situation A is given by Fc is equals to m1 times 5.8 divided by m1 plus m2, so this is 6. Then the contact force is equals to 5.8 divided by 2, because we can simplify here, and this is 2.9 newtons. This is the force with which one block pushes against the other. For the second situation, the contact force is given by m1, which now is equals to 6, times 5.8, which is the frictional force, divided by m1 plus m2, which is equals to 9. We can again divide by 3, so that we have 3 and 2, and then 11.6 divided by 3, and finally this results in approximately 3.9 newtons. Now, for the second item, we want to calculate the acceleration. So, the first situation, the acceleration is given by minus 5.8 divided by 3 plus 3, which is 6. This results in approximately minus 0.97 meters per second squared. On situation B, the acceleration is given by minus 5.8 divided by 9, and this is approximately minus 0.64 meters per second squared. And then we finish the question. The acceleration is negative because the blocks are being slowed down until they stop.